How does observation collapse the wave function? Imagine a tiny particle like an electron or photon that can be in many places at once, like a ghost haunting multiple spots simultaneously. This strange idea comes from the superposition principle in quantum mechanics, which says particles can exist in multiple states until something makes a choice. The wave function is the mathematical way scientists describe all these possibilities together. Think of it as a cloud of potential locations or states, spreading out in space and time. When no one is looking, the particle remains in this fuzzy superposition, behaving more like a wave than a solid object. But the moment you observe or measure it, something weird happens. Suddenly, that cloud of possibilities collapses into just one spot or state. It's as if the act of looking forces the particle to pick a single outcome from all the options. This process is called wave function collapse, and it's one of the strangest puzzles in physics. Why does observing cause this change? That's still a big question. Some scientists think the measurement process disturbs the system enough to break the superposition. Others believe the environment or the measuring device becomes entangled with the particle, causing the collapse. This idea is called quantum decoherence, where the environment's many particles act like a giant noise machine, making the superposition appear to vanish. But decoherence alone doesn't fully explain why only one outcome is seen. Some theories suggest that collapse is a real physical process, triggered spontaneously or by gravity. Others propose that all possible outcomes continue to exist in separate, parallel worlds, known as the many worlds interpretation. This means that when you observe a particle, you are just becoming aware of one branch of a vast multiverse. Experiments are ongoing to see if larger objects can be put into superposition, which might help us understand this mystery better. From a weird science point of view, it's as if reality stays in a fuzzy, uncertain state until someone or something makes a measurement. The famous double slit experiment shows how particles act like waves until observed, then behave like particles. This quirky behavior highlights how strange and counterintuitive quantum physics really is. Understanding how observation causes wave function collapse is key for developing new quantum technologies like quantum computers, which relying on maintaining superpositions to work. It also plays a role in quantum cryptography, where the act of measurement can secure information by making any eavesdropping obvious. So, in simple terms, observation collapses the wave function by forcing a quantum system out of its many possible states into just one. It's a process that's still not fully understood, but it's at the heart of the weird and wonderful world of quantum physics.